Most of you are probably familiar with the BIM-M Initiative. Today's webinar is going to be a more focused look on our BIM-M Benchmark Project, and specifically to issues related to mason contracting. Our team here at Georgia Tech includes myself, Russell Gentry, John Haymaker, who is on the line today but traveling, so he may or may not be able to join in audibly. Brian Lee, who's a graduate student in the School of Civil Engineering here at Georgia Tech. Also, our benchmark project is managed by David Biggs, who's also the overseer of the BIM-M Initiative. And also want to point out that Daryl McMillan at the Masonry Institute of St. Louis is in charge of our interaction with mason contractors. So all of the issues associated with BIM-M and mason contracting are rolling up through Daryl. So he's an important contact for you as well. I want to take a minute and thank the PanCal Foundation for overseeing the BIM-M Initiative and the grants that are given to support projects like this. And so you should know that the primary BIM-M sponsors are the MCAA, the Brickworkers Union, the BAC, the International Masonry Institute, and the National Concrete Masonry Association, and we gratefully acknowledge their support as well. So today we're going to give you a summary of the BIM-M Benchmark Project. We're going to talk about workflows and some system modeling examples and explain what we mean by that. And we're going to go through in detail our first benchmark project where we're interacting with the mason contractor and trying to understand his workflows and where BIM tools are currently being used, where they might be able to be used, and how we might develop software for mason contractors in the future. And we'll focus on masonry installation of block walls, concrete masonry walls, and cast stone accents, and then we'll wrap up. Brian?
So part of what we're trying to address here with using these new systems of modeling is this kind of big idea behind 3 states of BIM implementation. One would be current no BIM, where a project would not have little to no use of BIM technologies, or current BIM, meaning that they're just now starting to incorporate some of the new products that are out on the line. And then obviously future BIM would be the ideal state in the future that we try to achieve. And right now we have these 4 main criteria in terms of the metrics that we're trying to measure. So quality, cost, time, and safety. So a little background on these metrics that we're using. In terms of what we're looking for in quality, generally we want to see certain things like the ability to lay certain pieces of masonry in a fairly accurate position relative to a BIM model or a CAD model. And be able to see a connection between what's on site and what's on the computer screen. Also being able to use proper units and accessories that are placed into the wall. So ideally you'd be able to represent these in the models as well, and the ones that are on site. And then cutting of units and openings as they're shown in the plan. So oftentimes you see that the plan is simply just a simple drawing, and ideally you want to be able to fully replicate what's in the drawings and the models while you're on site as well. And then ideally these would help to reduce costs in terms of the percentage of the profit that's lost due to any errors on and off site. Also controlling the cost estimation, and ultimately having a better layout to minimize these various cuts. And this kind of goes hand in hand with time as well. If you have a better coordination with other trades, or properly using the labor around the site, you could see great reductions in cost and huge improvements in overall quality. And ultimately, this all plays into the safety factor as well. If you have a better plan and better layout and better modeling, you'd see a better workflow on and off site. And then any of the materials, especially that are placed on site, you could reduce the number of accidents that you see. And so now, in terms of the BIM-M initiative, we break these down into 3 main categories of masonry project types. So one, you have the CMU and brick, also structural masonry, and then finally complex masonry It could be a mixture of these or also some special way of implementing masonry on the building. And in terms of the case studies, we break them down into 5 general phases for a project. Schematic design, design development, construction documents, contractor coordination, and finally subcontractor installation, which would be all of the mason contractors we have here today. And the current study we're looking at is the engineered Biosystems building on Georgia Tech's campus. And you can see this table here kind of outlines the overall matrix that we're trying to involve. And right now we're focused on the last 2 phases of the project, and specifically in CMU and brick because that's what the current building is using.
So let me reiterate that what we're trying to do as we shadow this masonry contractor and all of the paper flows and shop drawings and submittals and material moving in and off the site and all of the coordination that it takes to make this stuff happen, we're categorizing the various processes as what we would call current no BIM, and that means a paper-based workflow where you might be using PDFs or email, but you're really not exchanging electronic information, and we call that state current no BIM. And then we know that there are BIM tools available and certainly widely used by architects and engineers and to some degree by general contractors. And the kind of best practices using today's technology we would call current BIM. And that would mean that your processes are using the tools such as, you know, software estimating using tradesmen, for example. That would be, we would call that current BIM. It's really using the software to the best degree possible. And then, of course, our job here at Georgia Tech is to develop a vision for future BIM. What should future software that enables higher productivity in masonry design and construction going to look like, and how are you going to use it, and what training is going to be required? So this is the building that we're looking at. This is the Engineered Biosystems building. It's on our campus here at Georgia Tech. It is a very complex building with a lot of different materials on it, which helps us understand the complexity of a masonry project. It's about a $113 million building. General contractor is McCarthy, and the mason contractor is Jolly Masonry. And I really have to point out that Dave and Matt Jolly at Jolly Masonry have been tremendous assets and friends of the BIM-M initiative by kind of allowing us to shadow them on the job site and be gracious when we ask persistent questions over and over again. And why did you do it this way? Why is there a pile of sand over here? So we try to understand everything we can about the masonry construction process as part of this initiative. So again, just some of the stakeholders here in the project. And this is a BIM-enabled project. So this is a Georgia Tech has a strong BIM execution plan, which is available publicly, which describes how contractors and the design team interact together. This project features a shared model so that the BIM model created by the design and engineering team is shared with the contractor and is shared with all the subcontractors. There's not a separate subcontractor model. So this project has aspects of integrated project delivery based on the Georgia Tech BIM execution plan. And we really see this as the model for the future. And now I want to say something about workflows before I turn it back over to Brian. We're going to talk a lot about workflows today, and you may think about workflows. You may hear different terms: flow chart, process model, activity diagram, value chain map. And what you see on the screen are some Georgia Tech engineers working with a company, a manufacturing company that makes, I don't know, widgets, and trying to help them understand their process and what aspects of the project are value added. This is just one of many ways to understand your workflow, and it's incredibly important for us at Georgia Tech to understand Mason contract workflows, because BIM software tools are going to help facilitate a workflow, but if we don't understand your workflow, then the software is not likely to be useful to you. And so that's when we say workflows. Um, here's an example workflow created by Midwest Cast Stone. They were kind enough to share this with us when David and I were out in Kansas City earlier this year. I think that all of you in the mason contracting industry, whether you work to a standard workflow or not, I think it's important to think about a workflow even at this kind of sticky note level, and figure out what are all the decision points, what are all the touch points for the materials, for the information, for the drawings, for the BIM model, and frankly to share that information with us. And so this is, as we end our talk today, I want to come back to these questions. How many of you mason contractors document your workflow? How many of you, if you don't have a documented workflow, are willing to engage with us in a workflow process? That is, to speak with us, to help us understand how you work and where you see information models being helpful in your process, whether it has to do with the masonry supply chain, whether it has to do with the project schedule, or whether it has to do with geometric aspects of the project. Are you willing to share those with us? And do you believe in a standardized workflow? If you have a process that you use on every job that's proven to be successful, then you are likely to benefit from BIM tools. But if every project is different and is managed differently and is more ad hoc, then you're less likely to benefit from BIM tools. At least that's my point of view. So Brian, back to Brian.
So continuing along with the workflow process that we're talking about, one of the ways you can address this is through what we call a SysML, or systems modeling notation. And this is similar to if you've seen any kinds of business process modeling or UML that's used for other various processes. But in terms of this one program, which we're using is Magic, and they have the system of outlining either a building diagram or a block diagram, which can configure any kind of organization, or also the activity diagrams, which are pretty much the overall business process or workflow diagramming. And just a little quick key here, the blocks that you see labeled, those represent any kind of stakeholder. And if you look in the example on the right, the top one would be more of a generic outline, whereas the one below includes the instance blocks, which would be specific stakeholders. So you could start to bring in specific companies or any of the employees in a company. And also the block that's labeled central buffer, you'll see in the following example. Those can represent any items such as documents or supplies and materials laid out on site. The rounded box represents an action in a workflow. The diamond is a decision point, so this could branch off into multiple different routes in terms of your decision-making process. And then simply the filled-in black dot would be the start, and the white outline is a finish. And if you have multiple processes, as you probably often will, those could be marked as an N and with an X and a circle. So you might have multiple of those within an overall larger workflow process. And then the fork symbol here represents a linked process. So if you wanted to have an overview of the basic steps in an overall workflow, you could then have a linked process that would relate one of those action blocks to a deeper level of understanding in terms of a more detailed workflow. So we'll be looking at one of those in this next example here. And as you can see, we just have three main groups of an owner, architect, and general contractor. And some of these basic ones you might see would be the owner makes plans, and then while that's happening, they bring an architect on board to start making the design. And once that design is completed, as you can see, there's in the review design process a linked diagram. So in a second, I'll be linking to the more detailed workflow we see there. But if you just finish out this one, you notice that there is a finish of a sub-process by the general contractor where they begin the construction management process. And then overall, we would see the end of a project on the owner side upon hiring the general contractor. And here, once we bring in the linked diagram, you can notice that right now we're focused on more of a detailed workflow between the owner and the architect in terms of redoing the design. So once the owner receives a design, both parties would go through a development process, and then if it's ready, you see the decision point with the diamond there, and if it's no, they would go back in the development process. Otherwise, they would move forward in terms of producing the documents and drawings. So now we're going to go into the case study about the engineered biosystems building here. And generally, we have three groups of masonry that they're using: CMU blocks, brick, and cast stone. And so far in our process, we've really broken down into CMU and brick. And moving forward, we're going to be observing the cast stone processes. But what you can do in SysML is, as you can see, we can bring in images for any examples of the blocks that are being used. And currently, the CMU is all or mostly in the basement level, where they have various animals that will be part of a testing facility. And they're using 4-inch, 6-inch, 8-inch, single and bull nose, open bottom, and solid bottom beams. And then for the brick masonry, we see some glazed masonry for the facade, and also three types of main red clay brick. And you can bring in any images, as I mentioned before, or mention any specific instances of these blocks. So this is an overview of the stakeholders on this project. And at the top, we have the Georgia Tech owner team. There are a couple of related parties, but generally we can refer to them as Georgia Tech. And we've broken this down into the design phase and the construction phase. So on the design phase, you can see the architects are Cooper Carey and Lake Flato. And one interesting thing you can do with SysML is there are many other elements you can add to even just a stakeholder block. So for example, here we have the main contact that we've been in touch with on the architect side. And you can connect them to Uzun and Case and Yuku and Boyd, who are the consulting engineers to the architect. And then the architect actually early on in this project worked closely with the masonry team, the suppliers, and the subcontractors to try to work out exactly how they can successfully implement the complex masonry that's on site. And over on the construction phase on the right, we see McCarthy, who is the general contractor. And Jolly Masonry, once again, is a subcontractor. And here, you can even, instead of adding companies, you can add the specific people that are working on and off-site. So Matt Jolly is the project manager who mainly works off-site, but then he has the superintendents that he oversees on-site as well. So just kind of go over the beginning processes that we might not have too much detail in, but in the schematic design process, you would see the owner of Georgia Tech working with the architect to create a good workflow and some details on the types of masonry that might be used on site. So this could range from the specific, brick selection process, or just general schematic drawings that they do for somewhat of a preliminary design phase. And you can see at the end of this process, you can connect some SketchUp models and Revit models. So within the SysML diagramming platform, you can relate to these models and even have a file link to an outside program. And one of the link process within there is the selection of architectural materials. So this kind of breaks down into more detail just how many steps they would go through in just figuring out what type of brick to use. And one of the interesting ones you can see here is the dotted line block in the middle, which is labeled as a structured block. This simply means that you could have a repetitive process that's broken down further within an overall workflow. And so here, upon talking to the Cooper Carey team, we realized that they not only have some dry stacking samples in the office and on site, but they went out to the site to get a good view of the surrounding buildings at Georgia Tech to compare some of the masonry work on the facades, and ultimately comparing those drawings to the ones that they have in their office and their sketches that they've made. For the architectural contract document production, they define some of the wall openings in the building, and using this they have some of the masonry specifications and make the detailed construction documents. And looking at the link process here as well, you can really see the detail that they go into in picking out some of the masonry that's used on site. Mostly the size, color, and shape will refer to the brick facades, but also the CMUs would have multiple bull noses or double bull noses in terms of the doorways that they're using or wall corners. So a lot of decision making goes into this process, and you can accurately document them here in the workflows. So this might be breaking down more into the workflows that you'd be interested in directly, because now we're dealing with the general contractor coordination. So you can see at the left-hand side, McCarthy, we start with them in terms of receiving the model and the documents and the specifications. And if we just quickly go through this here, you can see that Jolly Masonry is brought on board relatively early in the beginning, produced their own shop drawings. So in addition to the documents that are created by the architect and the GC, the masonry subcontractor went in and created some of their more detailed drawings in terms of the specific connections and layouts they would have to do on site. And specifically for Jolly Masonry's workflow process. So in the beginning, they would obviously order the supplies, and this they would work hand in hand with the suppliers to figure out which types of blocks they're using, how many they would need, how the shipments are coming in. And they would also be coordinating with the GC to work out where to lay out the various materials or the equipment that's being used in terms of loaders and lifts that are brought on site. And here we see a link process for the reviewing of construction documents. So during the installation process, they'd be continually reviewing the documents to make sure that the construction process is going smoothly, that they're properly coordinating with other teams, because you have the MEP contractors, the lighting, the GC in general, and also all of the supplies have to come on site. You have to map that out properly. Otherwise, you have a lot of wasted time and a lot of costs in terms of moving around the materials on site.
So part of our presentation today is to identify aspects of the case study that we're working on where there are opportunities for BIM. And so one thing that's interesting is this is a very complex building architecturally. There's structural steel that is coming out through the masonry to carry sun shading. The brick on steel stud backup wraps around the steel studs to give the appearance of a deep masonry facade around the windows, and there's a cast stone sill at each window opening, as well as ganged window openings with an enamel metal panel that's fit between certain windows. And in addition to that, there was at one time up to 23 different brick types considered for the building, including glazed brick types, including what you can see here is a little kind of a header course, if you will, at the relief angle that's recessed. And all of these design ideas were played out in mock-up. You can see here the through-wall flashing being put in here. So all of this was put into a very expensive set of mock-ups, and this is the final mock-up that's still on the site. And so the question we have is there a BIM opportunity for a virtual mock-up? And we've seen Mortenson and their virtual design and construction and other general contractors really take advantage of sometimes a BIM tool like Revit, but also even SketchUp in building really, really detailed mock-ups of masonry assemblies. And if that's something that mason contractors see value in, then we need to know that, because that's something that we will focus on in our future work. Again, just saying a few things about the EBB building as we move forward. It's a brick building, veneer on metal stud with these deep brick openings. It's got cast stone accents at every window as well as at the top. In this metal panel, shades coming through on the south facade, and then of course relief angles at every floor. The primary frame is cast in place concrete. The BIM model shows perfect geometry, right? So that's something that's important. The BIM model is perfect, or we would say that we're supposed to build to the model, and it is shared with all of the general and subcontractors. So it is made available to the subcontractor, and in this case, Jolly Masonry used the BIM model to some extent in their process. But what we found is that, and we're surprised by the fact that the mason contractor had to basically remeasure the building in its entirety upon the construction of the frame. And I'll just give you some aspects of the details that they found that were not right when they got ready to install the veneer. And this is a schematic drawing. It's not the BIM model. It's a much more simplified model. And this is something we want to emphasize is the BIM model is quite complex, and it contains a lot of information that you really don't need. For a mason contractor, the BIM model that we're looking at is not really that useful. But this is a view into the BIM model. This is a very simplified view into the BIM model, which represents your point of view and only what you're interested in. So the numbered circle 1 represents the control joints on the facade. The circle number 2 represents the relief angles, which are welded onto embeds in the concrete frame. And in this case, there were areas where the relief angles needed to be cut out because they were in the way of that enamel metal panel. In some cases, as shown on the number 3, the relief angle was not level with the brick coursework and had to be reset. In some cases, the relief angle was projecting through the masonry coursework, so it had to be trimmed back. In circle number 5 here, in some cases, the steel stud rough opening of the windows were not necessarily properly aligned with the way that the masonry was going to course out, so the window had to be adjusted. And I would say that these are examples of problems. Not all of these problems happened on this site, but these are the sorts of problems that were anticipated by the mason contractor when he had to invest a man-month of superintendent time in kind of getting ready to apply masonry to the facade. Just a few other ones to note. There was a set of outriggers coming out through the masonry facade that were supposed to be, if you will, integrated or lined up directly with the mortar joints, and those had to be re-welded onto the facade. And there were some places where the waterproofing had to be changed because this was a below-grade installation, and there's the specifications called out different application of waterproofing below grade and above grade. So again, those of you who are masonry contractors, you deal with this all the time. But then what method do you use to communicate these changes to the miscellaneous metals installer, to the waterproofing and contractor, to the steel stud installer, because they have to do some rework on their scope before you can start your scope. So we see this as a tremendous opportunity for mason contracting in BIM-M. And here's just one example kind of zoomed in. Imagine we look at a window opening and the rough opening is already there. It could be in CMU, it could be in steel stud, but we know that the masonry veneer is going to go on the outside, and it's going to have to be aligned with the opening. And you spend a lot of time with a tape measure or maybe with a laser scanner or a total station out checking the dimensions of things. And we can imagine a simple BIM interface for window openings where you just measure the 4 corners of the window, and you can know very quickly whether you're in or out in tolerance well enough to continue with the masonry installation. And again, we're speculating here on these sorts of applications, and we need feedback from you as to whether these are useful or not. Brian?
Thank you. So part of understanding the workflows involves really observing the sites and also working closely with subcontractors like you. So here we see part of the brick facade installation process. And in the beginning, for any documentation, you have to have the raw data that you acquire. So I actually spent a few days out on site to observe day-to-day processes and see how this wall was put up from start to finish. And in this picture here, you see that they're using 3 types of scaffold systems. On the far right, you have the orange dotted section with a Fraco. And then in the middle in the green, you have a pump check scaffold system. And then finally, a swing stage on the left. And the way that Jolly Masonry decided to split up the groups here, the crews were split into 9 masons and 5 laborers. And the masons are split up with 4 on the Fraco, 3 on the pump jack in the middle, and 2 on the swing stage. And then the laborers that are assisting them had 3 on the Fraco, 2 on the pump jack, and none on the swing stage. So part of this has to do with the layout of the site, which I'll go into a little bit more detail later. And also the fact that they all have to access the scaffold systems only through the Fraco. So if you see in the image here, there's a temporary scaffold platform that's been constructed below the Fraco, and every member of the crew has to enter and exit through there. So this obviously causes some issues in terms of access throughout the day. So you can see in the far right, they actually have a mobile toilet unit, if you will, that's located on the Fraco, so that all the day's process can be taken care of, and they only have to go once or twice, hopefully, for lunch breaks as well. And each day they use approximately 10 cubes per day, and you can see some of the cubes that are laid out in the bottom half of the image there, and approximately 4,500 bricks and 31 bags of mortar. And overall, the whole facade should have taken approximately 80 cubes, 42,000 bricks, total of 283 courses, and those loose lintels or the cast stone accents on the windows. And generally, the daily schedule was at about 7 a.m., 2 laborers would come on site to start mixing the mortar for the day. And then overall, there were about 10 hours of work with about a 15-minute break at 5:30 and a 30-minute lunch. So here we can take that raw data that we acquired and start to implement it into a diagram process. So this brings back the block diagram that we mentioned earlier. And this allows us to just show the breakdown of the work crew on site. So you can see that it's divided into the 3 scaffold systems and the number of masons and laborers on site. And John Anderson was a superintendent that was overseeing this whole process. So he would be the one who would be reviewing these day-to-day workflows and that breakdown of who's on which scaffold system. And here you notice that they're kind of applied with a generic name, such as laborer 1, 2, and 3, or mason 1, 2, and 3. But you could see that in your own documented workflows, these would be labeled specifically with the workers that you have on site. And then you can move them around in terms of which section that they're working on day to day. And this diagram of the activity or the business workflow is taken from that raw data as well. So you can see that the mortar mixer arrives, 2 of them at 7 a.m., and they start mixing the mortar. And the mortar is listed as an object here, which is then an input into the machine operator who's using a loader, which is also a object. And they will be moving the materials, including the mortar, around on site to various locations. And they would also, the mortar mixer would also coordinate with the masonry crews to determine how much would have to be mixed at what points in time, and when the day's work would be finished. And once the rest of the crew arrives at the masons and the superintendent, they begin the preparations for the day. And this will include getting into position on the Fraco to any of the other neighboring lifts. And the supplies that are being brought on are mostly the red clay brick here. The glazed masonry is being used on a different side of the facade, so that's not included in this observation that we had. But you can see that the time breaks are incorporated into their activities in the middle of receiving materials or the general laying of brick. And finally, this ends in the day's tax and organizing the leftover materials and supplies on site, and ultimately exiting the work site. And here we see an image of the installation of some of these brick ties. And this was done after the waterproofing was laid down and before the installation was done. So you can see where the laborer is actually taking measurements to recheck the spacing between the brick ties. And there's a close-up image on the right of the actual installation. So these are just some of the processes that you can start to document in very good detail in terms of working out what they do day to day. And now we have a Revit model that's taken of the elevation and section on the brick facade that we're observing. So as you can see from the image earlier, this is the same view that we're getting. And ultimately, you could tie these into any of the system of workflows to allow some of the subcontractors to be able to reference which models are being used and which ones need to be updated. And here you could do the same thing with some of the drawings. So these show the actual work that was being done in terms of scope of these 4 drops that are on site of the brick facade in the southern part. And again, there's the section on the right that correlates with the actual model image earlier. So part of the observation process, what I was able to do was take a time lapse. So here you can see each day 2 images taken in the morning and afternoon, and we start with the Fraco lift being constructed. And you can see at the same time the green pump jack and also the swing stage are being implemented to the left. And furthermore, the supplies are being brought on below. And you can see now in the installation process, as it's going up day to day, that they have the insulation laid out and then each layer of brick and each course being added day to day. And ultimately in this process, the only thing that's going up and down would be the Fraco lift, because once again, they have to enter and exit the other scaffolds through that lift day to day. And so now we see ultimately the finishing of the facade and the takedown of the scaffold systems. And if you notice, that red crane is the only thing that prevented them from using 2 Fracos, which they usually would do in this process. And now we'll turn it over back to Russell to talk about the basement level.
So one aspect of this building is a basement level that the designer calls the Vivarium level, which is for animals. It's essentially a veterinary facility, and so all the basement level has to be washed down. So all of the interior walls are concrete masonry units. And so you can see here the Revit model of the concrete walls. And, you know, if you zoom in a little bit, Revit is really good at making walls look like they're concrete block, but really that's just a convention. There's nothing inside of Revit, or there's no details about masonry inside of Revit. That's really just a 7 5/8 inch thick layer with wallpaper on it that makes us know that there's block. But none of this coursing is really appropriate. None of this is really going to happen this way. And you can see when you cut the Revit model open, it just kind of looks hollow inside. And that's okay. That's not really a critique of Revit, because at this level of detail, say LOD 200, we don't need more information than this in the BIM model, and we don't want to carry a lot of additional information. But if you're, for example, trying to do a takeoff of this interior, and you want to understand how many blocks of what types to order, the information's just not here for you. And so that's something that's important for BIM-M, is to say, how do we take this model from the architect and build it up and give it more legs so that the kind of questions that we have as mason contractors can be answered? How many double bullnoses do I need? How many lineal feet of bond beam am I going to need? Where do they go? How am I going to dead end the block walls into the concrete columns? So those are real questions, but unfortunately at this level of development, the BIM model just can't help us that much. Another thing that's interesting is what we would call rationalizing the control joint placement. So this page indicates where the architect calls out how the control joints in the walls are to be laid out. At changes in wall height, there's supposed to be a control joint. Every 25 feet, there's supposed to be a control joint. At changes in wall thickness, there's supposed to be a control joint. At above movement joints, below movement joints, near the sides of doors. But they're not actually laid out by the architect. Instead, this series of requirements or rules are specified by the architect. And then in this case, the mason contractor has to create a shop drawing which shows where the walls go up and down, because we have some walls that go up 16'8" to meet the bottom of the slab, some walls that are at 10'8", some walls that are at 10'0", and then all of these little blue dots represent the control joints, and this goes back to the architect as a shop drawing that has to be approved. And I believe in this project, I may be misstating, but I believe in this project, this was somewhat of an iterative process to get this layout of control joints approved. And is this an opportunity for BIM? We think so. This looks more like blocks. So if we look now, we're looking at the plan of the basement, and we see blocks in place. Now it's clearly more like blocks. And this little example was given to us by Tom Cuneo at CAD Blocks. He was kind enough to quickly generate some of the interior elevation so we can demonstrate to you what you might call best current practice using available BIM tools. And so although the CAD Blocks is not integrally linked with Revit yet, nor is Tradesman integrally linked with Revit yet, we would hope that through our BIM-M initiative, we will develop the means by which these tools can be better linked. And so again, if you zoom in on the CAD Blocks model, you can see that each masonry unit is labeled. You can see the bond beams where necessary. You can see the bull noses at the door openings. And you can even start to see where you're going to have to make cuts. Because where you see the blocks overlapping, you can see that we have partial runs, and there's going to be cuts required here. And the model is almost getting to enough detail where you could imagine doing this cutting off site. If you believed this model, and we do, then you could do some of this block cutting off site and not have to do it down in the basement with all the associated dust control problems. And so we see this as the best kind of current state BIM, and look forward to more implementation of software like this on projects like this. Okay, we're going to go back to the Vivarium. Brian?
So everything that Russell was mentioning about the decision points and the various coordination tasks like we do, you can imagine in a good or future BIM implementation, those would all be part of the documented workflow. So those could all be specific action blocks within a SysML diagram. But now going back to the Vivarium level, this was taken from the observation of what's currently being done at the EVB in the basement. So you could see that Danny League, who is the other superintendent, he arrives and begins some of the pre-work. And then the laborers come on site to start mixing the mortar, and also the cut man has to cut these CMUs down to whatever sizes they need. And as Russell mentioned, obviously you could imagine doing this beforehand or coordinating it better for a workflow. But here they're still having to result in cuts that are being done on site and coordination that's being done all in the basement level as the work happens, as the various issues that occur in the work task day to day. And this leads to a review of the work task that has to be done because of the certain errors that are happening or because of various mishaps or lateness of certain supply deliveries. And overall, this also leads to another linked activity when they're checking for these errors and the rework. We noticed that there was one specific instance in the Vivarium where there was a problem with the coordination of other subcontractors in terms of where the walls were being laid out and which structures were happening where. So actually Jolly had to bring in a third party to look back into the documents and figure out what exactly might have gone wrong or if there was anything wrong to begin with. And so if we look in that process with more detail, we see that the other superintendent, John Anderson, had to bring back the drawings and remeasure the site control lines in the basement level to figure out where the error was being done. And ultimately, actually, Danny League had to tear down one wall that was already constructed and reconstruct that process. And so obviously this is a huge time waste and cost waste for the installation process in the basement. And with a well-implemented BIM process, all of this could be taken beforehand or in real time with the other subs that are on site. And afterwards, they continue the supervision of that rework to make sure there are no other further errors on site. And here we see another model image that's taken from the Revit model. And one downside to the current state of various modeling programs like Revit is that they don't actually represent masonry. They don't do justice to what masonry actually does on site. And so here we see one of those cast stone pieces actually cutting through a brick masonry on that windowsill, which obviously wouldn't make any sense in the real world. So you can imagine that if some BIM program is properly implemented, you could have certain errors like this in the model be avoided. And in the actual on-site installation process, this will make the workflow a lot smoother overall. And these are some of the drawings that are taken from the package I was given from the masonry subs. And here we see some of the stainless steel strap anchors for the brick walls that are going up. And on the right is a section of one of the cast stone pieces on those sills. And so all of these can be mapped into some of the workflows that not only the masonry subs are using, but also the general contractors, so that you can have a streamlined process in terms of the exchanges of documents and also the installation on site. So just to talk about some of the metrics that were mentioned earlier and why they're important for our overall process and for BIM implementation for not only mason contractors but the other subs on site. We noticed that some of the scaffolding systems had to be adjusted or moved around because of that one tower crane in that facade workflow. And that tower crane has to actually remain there from start to finish of the job. And the masonry subs expected to come in and finish their work in the middle of that whole process. So obviously this would be a huge pain for coordinating the not only just the brick facade work, but also the main access to the basement is actually located right around the tower crane. So that means that all the supplies, all the materials have to go through there. So ideally you'd be able to work out a better solution to organizing how the brick's being done when they're coming in to actually do their work instead of having to coordinate around this typical tower crane. Also, the facade that we were looking at in that time lapse, originally the plan was to be 10 days of work from start to finish. But obviously that did not take that shortly. As I mentioned, it was taken 2 images per day, and overall that was about 30 days of work. So one thing that we like to understand is what's causing these delays. And these are things that could be ultimately addressed with BIM. And currently the BIM models, as Russell mentioned, they don't really do the actual work and the detail that goes into masonry justice because they can't document the block-to-block joints and also a full wall properly in terms of working with the other systems in the building. So how can we use things like CAD blocks or other detailed mapping systems to fully integrate them with current and future BIM applications in terms of working through a masonry sub process. So we need to be able to identify some of these potential gains that we have in a BIM-enabled masonry workflow, and not only quantifying them, but being able to apply those various elements into an overall project. And that's what we're trying to do with the BIM benchmark project that we have. So one of the things that we're doing to further this process is we'll be teaching a course this coming fall. This will be a joint course in the building construction, civil engineering, and architecture departments here at Georgia Tech. And what we're looking to do is find current, recently finished, or ongoing projects that have very good examples of design and masonry teams working together to make a any kind of CMU brick, structural masonry, or any complex masonry projects. So here the one we're using right now is the EBB building for CMU and brick. And there's another building in Ithaca that's an apartment building that uses structural masonry. And in the bottom we have an example of a complex masonry at Yale in their health sciences building, which uses some complex forms and shapes for the brick facades.
So we're wrapping up now. We're ready for your questions, but I want to reiterate that what's really important for us at Georgia Tech is that we're writing a kind of a vision document and ultimately a software specification for BIM for masonry. And that's going to go to software vendors like Autodesk and Bentley and Tekla for their comment and hopefully their implementation in future versions of their software. In addition, we want to include and assist companies like Tradesman's and CAD's Blocks, which are software specific for the masonry industry, to integrate with the big tools, which are not really likely to touch on the details of masonry. So we see a future where there'll be specific BIM tools for masonry, along with more masonry awareness built into the major BIM tools. but this is only going to be successful to the degree that we look at a wide range of masonry details, masonry projects, masonry workflows, because the software is meant to really facilitate what you do, and that's build masonry buildings. We need to know what the hardest part of the projects that you're doing are. Where do you find opportunities for increased productivity, especially in the flow of information, because ultimately that's what BIM is about. And if you're willing to work with our student teams this fall in the BIM Benchmark Project, we would love to have them on your job sites. If you can meet with them remotely through Skype or a webinar like this and tell them about what you're doing, it's really the student's job to create these workflows. So we're not asking you to become experts in system modeling language like Brian is. What we're asking you to do is to do the sticky note workflow for us and let us understand how that can go into kind of a unified workflow for the masonry industry. And if you've never had one of these lean value stream mapping exercises in your organization, around the country, most schools of engineering have these manufacturing extension partnerships, and they will work with you to document your workflows. I know that Georgia Tech has an outreach organization that does this at no cost to our state's industry. So again, and I can reiterate, tell us what your problems are. Not all problems certainly can be solved using BIM, but we know that many of them, or we hope that many of them, can. Again, here is our contact information here at Georgia Tech. I'm Russell Gentry. My colleague John Haymaker is on as well today, remotely. And we want to get your feedback on how we're doing and what you think this project could be doing for mason contractors. Again, Daryl McMillan at the Masonry Institute of St. Louis is overseeing our interaction with mason contractors, so you can email him, or David Biggs, who's managing the overall BIM-M initiative. And so that's all we have here at Georgia Tech. We will stay on the line for your questions.
Okay, Russell, it looks like we have 2 questions. We'll start with the first one, or it may be a comment. With respect to the CJs, the code requires them to be shown on the drawings by the designer. Very important for the structural engineer to locate the CJs in the structural CMU for his or her design. For example, bond beams, shear walls, intersecting walls, and structural flanges, etc. Any comments?
Yeah, I agree with you, and I think there's always a tension between the design team who thinks that they've done their job by describing something perhaps in a specification, or a construction team who says that they have inadequate information. So in this case, Jolly Masonry, being a great team player, was willing to take the rules and actually lay out the construction joints. These walls were not load-bearing walls. They weren't carrying any vertical load, and we're in a low seismic zone here in Atlanta. So you know, I don't think there were huge issues on these concrete masonry walls vis-a-vis load. It was almost more of an aesthetic decision about where you want the construction joints relative to, you know, as you're walking down the corridors, do you want them to line up? Do you want them to disappear? So, but I agree, and I also think that that points to something that we need a better Revit model for control joints, because the architects and engineers have embraced a BIM process, but Revit cannot, for example, take those rules that I described to you, every 25 feet next to a door, etc., and lay the joints out. But that's actually something that we're going to be exploring in our next phase of BIM-M, is how to implement a plugin for Revit that does some of these easier tasks, like laying out the control joints. So by the time the mason contractor gets the BIM model, they're already there, and that would save the mason contractor time and money.
Okay, we have a second question or comment. For a mason contractor standpoint, several items that were out of model were shown on this project. In BIM, who would identify out of model conditions? The installing contractor or the mason? It seems the real strength of BIM would be to immediately flag change events before a mason would have to identify them.
I think that's a brilliant comment. I don't know who made it, but I think that's a construction process issue, and the question is, who is responsible for identifying that elements that have been installed on a building are not where they're supposed to be? And in this case, my enthusiasm for Jolly and the way they work is clear, because I can say that they took it upon themselves to remeasure the facade before they started masonry installation, because they knew that it was a complex installation, and if they just started installing without making those checks, things might go wrong. And so, but what we would imagine, and I know that people like Leica, the Total Station people, and Autodesk are working on ways of quickly measuring a building as it's being constructed, not laser scanning per se, but building a BIM model that has key dimensional information updated. And I think that that is ultimately going to be the responsibility of the general contractor. I don't know if there's any general contractors on the call today. Hopefully I'm safe by saying that. But to me, that's their responsibility, because there's at least 5 or 6 different trades who can put stuff on the facade in the wrong place and screw up the masonry.
Okay, we'll move on to our next question. What suggestions for training in Revit do you have?
That's a great question, and I would point to you to David Biggs and Art Tuish, who are developing some training modules for Revit. At this point, to be completely honest, I think that perhaps one person in a large mason contractor's office should start learning Revit, but it's an expensive investment in both time and training, but that I think in the long run it's going to pay off. And I think that that same person who learns Revit will ultimately be comfortable with a tool like Tradesman's or a tool like CADS Blocks. And so it just depends on the size of your firm and whether you want to bring that in-house and have that, maybe your chief estimator or someone like that, learn the tools. But I think I understand if you're a mason contractor, your reticence to spend that money right now. And what we're trying to do as part of the BIM-M initiative is to define the value proposition so that maybe in the next year or two, if we're successful with our work, it'll become clearer to you that you can invest that money and get a return on that investment. But there's no magic. It's a tough tool to learn. It's a complicated tool because it does amazing things. And I'm not saying that just specifically about Revit. Many of these BIM applications can be incredible time savers if they're implemented in a work process that uses them.
Okay, moving on to the next question. If we participate with you, we might not want to highlight problems on our projects. Can you keep our identity and the project location anonymous?
Yeah, that's a really hard question. I would look, I think that there's one aspect of this is that we're trying to do something for the entire masonry industry, and we know how litigious construction is in general, but I think that what we would ask you to do as a mason contractor is to scrub the information in a way that you felt comfortable for us disclosing it. And I think it's always an issue, but at least on the project that we're working on right now, there's quite a bit of goodwill on the project The project is for Georgia Tech, which helps us have access to the project. But I completely understand your concern. So I would be glad to speak with you offline, either by phone or on a conference call, and we can find a way to work together. I think that what we might do is to generate a generic workflow where we talk about your processes, and you might show us photographs from a wide variety of jobs so that no one image comes from any specific projects because you've worked all over a certain region of the country or have 10 years worth of work. So we don't need such specific information that that you're going to feel uncomfortable talking to us. Let me put it that way.
Okay, moving on to another question. I need to be able to get wall vector information from the architect before I create my own model. Revit did not seem to do this very well.
I'm going to ask the questioner to clarify the term vector. I don't understand a wall vector information. Is that like the center line of the wall in plan? I'm just not. I don't understand the question.
These are the points of the lines and shapes.
Okay. Okay. So I think maybe I understand a little better now. So Revit right now just models a block or a brick wall or even a composite wall that's CMU with brick veneer as a solid, and so there's no real way of understanding the pattern or the coursing in Revit right now. And part of our goal for all BIM tools is to help the software vendors better understand masonry and to convince them to put a little more information in the software in the next couple of versions, so when you try to extract those features that you need from the model, you'll get what you want. And so in this case, you have my email right here on the screen. I would really write that out, exactly what you want, what you would like to get from the model, and why can't you? And that's something that's actionable for us in the next BIM-M project.
Okay, moving on. Did Jolie do its own BIM model, use the architects, use the CMs, or other?
So this project is executed under what we call a BIM execution plan, which is from the owner, and it's a shared model project. So the architect is actually paid during construction to update the BIM model. And so there is a BIM model update every, I don't know, 1 month, 6 weeks. Brian's shaking his head yes. And so that is a shared model by everyone. And this is part of what we call integrated project delivery. It's by far, we think, the best way for BIM projects to go. And so it is not a separate contractor model, but the contractor has input to the architect in terms of the way the model is constructed so that it is useful for things like clash detection and sharing with subcontractors. So to my knowledge, Jolly did not create a separate BIM model, but I believe that Matt is a Navisworks user, and he's probably doing some of his own project planning and clash detection using Navisworks. But again, I'm likely to get scolded by Matt for speaking for him. So take that for what it's worth.
Okay, moving on. This appears to be a comment to a previous question. It says the question really goes to how building model information flows from the original design to the mason contractor without having to recreate our own model. Did you have a comment on that?
I do, sure. I think that is exactly the intent, is that at some point we're going to be talking about exchanges, and that's the time when you query the architect's model and you get what you need out of it, and you don't have to go back to the architect's model anymore because it's got way too much stuff in it. You don't really care where the toilets are, you don't care what the paint colors are, etc. So I think if, again, it's important for you as mason contractors to tell us, Georgia Tech, what it is you want from the model. I need the center line of this wall. I need to know where it starts and stops. I need to know where the window openings are. I need to know where the embeds are. I need to know what the spacing of the ties are. Whatever you think is important, because we know you can't get that from the current BIM model. That information is not there. So you have to hunt it down from the specifications, or you have to go back and forth between a structural engineering BIM model and an architecture BIM model, which may or may not be linked. We understand that they're not integrated. So I think one of the best things we can get from you is a laundry list of what you want. It sounds like many of you are playing with Revit or have Revit in your offices, and you're opening these models, and you're not able to get the information you need out of them. And we understand.
Okay, the next question is, will a transcript of this webinar be available to contractors who could not attend today? I can actually answer that question. The current webinar is being recorded, and it'll be available on our website, also on YouTube, and on the BIM website within the next couple of days. So it can be viewed again or accessed. And the next question was the same thing. Will this webinar be available to show to others that could not attend? Absolutely. Again, you could view it on the MCAA website, on YouTube, or the BIM website. Moving on to the next question. The attendees can see the BIM-M website by developing advancements at BIM-formasonry.org. The next question, comment, I'm creating a shop drawing and the work is redundant. I want to use the work that the architect has already done to use in my model. How would he go about doing that?
Well, I think that right now there's some somewhat manual processes where you can export the geometry from the Revit model to a flatland CAD and then draw on top of that. That's what a lot of people do now. The the CAD block software that we showed from Tom Cuneo, his service actually generates those shop drawings. That's his business. So I think that he's developed a workflow that is based on either an AutoCAD drawing or a Revit model. So I think that technology is and Tom would have to speak to this directly, but I think that technology is maturing and it should be available to you in the next year or so.
Okay, and our last comment is, later this summer and fall, BIM-M is launching its educational program. One program will be using digital tools and applications, or apps. It is intended to help contractors with digital tools that are simple and available now. Hopefully this will show the value of contractors to using digital tools too, and lead them to looking closer at BIM.